Here's a quick simulation of early retirement of New York State's nuclear generating units. We're looking at a long-term generation profile for New York, adding efficiency and renewables, as well as in light green a long-term purchased contract. What we see when we look at carbon dioxide is a long-term declining trend until the scheduled retirement of those nuclear units. And what I'm going to do now is one by one, I'm going to retire the existing nuclear units starting in 2017. And I'm just doing this in no particular order. And it'll be the retirement of roughly 6,000 megawatts. Okay, and now what we'll do next is we'll resolve the simulation. And what we'll see now, instead of that gradual decline in carbon dioxide emissions, we're going to see a dramatic increase in carbon dioxide emissions. Okay, and I just fast forwarded a little bit there. And so now we see the dramatic emissions. We're going to look here also at sulfur dioxide emissions. We see an increase, and nitrogen oxide emissions, an increase. Looking just quickly at the cost, we've assumed those capital costs have disappeared, so you don't understand the cost impact until we show you what happens when we no longer assume that natural gas is $3, but let's say natural gas is more like $5.50. Fast forwarding here a little bit again. Okay, and the other thing you have to understand is that the generating capacity has been reduced by 6,000 megawatts, and so again, let's use natural gas. Replace 6,000 megawatts with natural gas. Generating capacity, so now we're maintaining the same amount of generating capacity and reserve capacity. We'll add that. Now we'll look again at the cost and we'll resolve, and we'll see that we'll have an increase in generation costs here under this scenario. Fast forwarding again, so we see the whole 20-year profile.